Slide number 37. This exposes the left dust shield so that we can remove it. On the left and right side of the shield we find two small slotted openings. With the aid of a screwdriver placed into the slot, we can apply moderate pressure which simultaneously pushes the shield upwards and towards the rear of the machine. With this pressure we can release the shield from the bracket which holds it in place at the front of the machine. Slide number 38. We use the same procedure in order to release the right side of the shield. Stop the player if you need additional time. Slide number 39. Now that the left shield is loose or free in the machine, let us show you how to get it out of there. First we place our right hand indicator finger under the velocity control cable, as shown here. We will use the middle finger in order to lift the shield out of the machine. Slide number 40. We also use the left middle finger to hold up the left side of the shield. This has the advantage that both of the indicator fingers are kept free so that we can use them in order to remove the shield past the somewhat more delicate steel tapes called tilt and rotate tapes at the rear of this cavity. Slide number 41. Now we carefully move the left shield slightly towards the right and front of the machine in order to be able to lift the rear edge past the rotate and tilt tapes. At this point we need to be careful not to use any force in order to prevent damaging the tapes. It is also possible to move the shield too far to the front, thus causing it to lock under the keyboard. Should this happen to you, make sure that you first free the shield under the tilt and rotate tapes, and then make a new attempt at lifting it past the tapes. As mentioned earlier, use your indicator fingers in order to gently guide the tapes out of the way where needed. Slide number 42. Upon having passed by the tilt and rotate tapes, finally we only have to pass by the velocity control cable in order to completely remove the left shield. At this point, you should stop your tape player and follow the procedure which we just explained on your own machine. Once you have removed the left shield, examine the parts which hold the shield in its position. Before continuing with this program, you should reinstall the left shield and then remove it again as many times as you need it in order to become reasonably proficient at it. Notice also the carrier return cord, or cable, barely visible under the shaft called print shaft. The dust shield is placed under the cord. Lack of care during the dust shield removal can cause the cord to come off its pulley on the left side of the machine. Slide number 43. Now depress the carrier return key and then turn the hand cycle knob until the carrier stops in its extreme left position. This will expose the right dust shield so that we can remove it too. Slide number 44. On the left side of the right shield, we also find one of these elongated openings for the screwdriver. Again, we apply a bit of rearward and upward pressure to release the left front edge of the shield from the supporting bracket. Slide number 45. Before we remove the shield, be sure to examine the position of the velocity control cable in the small clamp or bracket at the rear of the right shield. Notice also that the cable goes through the opening to the right of the clamp. Slide number 46. Once you know how the velocity control cable is positioned, use your left hand in order to bring the left end of the shield slightly towards the front, and then simply pull the shield towards the right a bit. You will notice it come out of the retainer clamp on the right side of the machine. Once you have it out, again examine the clamps which hold the shield in place when it is in the machine, and then reinstall and remove the shield a few times until you're reasonably sure that you can remove and reinstall it without affecting the tapes or the cords. When you're reinstalling the shield, it is important not to pinch or kink the velocity control cable. Make sure that it is positioned in the indicated opening, and then make sure that the left end of it is held down by the hook or clamp in the shield. After this has been done, leave the shield out, and then keeping your hands out of the machine, turn it on and off a few times. While doing it, take some extra time to examine the results. You should trace the links to the switch, to the motor, and everything that is caused to idle together with the rotation of the motor. Slide number 47. As a first step, we locate the on-off switch at the rear of the machine, or on older models underneath the keyboard. Slide number 48. The motor transmits its torque or twisting force towards the front of the machine via this cog belt. A cog belt is a belt with teeth in it. These belts are designed to eliminate slippage on the pulleys. Slide number 49. In the center of the machine, we find that the belt drives a substantially larger pulley called the hub pulley assembly, or the drive pulley. Observe the parts next to the hub pulley assembly. Notice that the shaft to the left of the pulley does not rotate when all you do is to turn on the motor. In order to make it rotate, you should depress a character. When you depress the character, the shaft did indeed rotate. What happened is that we activated the parts indicated in this picture. These parts constitute a clutch, which is used every time the machine prints a character. In spite of the fact that the clutch is really the print clutch, it is called cycle clutch. Due to this, the hub pulley assembly is often called cycle clutch pulley. The hub pulley assembly is directly connected to the shaft situated at the right of it. This shaft is called operational shaft. Every time the hub pulley assembly turns, the operational shaft turns also. You should think of this operational shaft and the hub pulley assembly as the source of positive power in the Selectric typewriter. Or if you're an old typewriter serviceman, think of it as the power roll of the Selectric typewriter. Slide number 50. Here the red indicator points at the hub pulley assembly, while the yellow indicator points at the operational shaft. When the motor is turned on, the operational shaft turns continuously. We then say that the system is idling. The hub pulley assembly, together with this continuously turning shaft, provides us with the mechanical torque which carries out the majority of our Selectric typewriter functions. The hub pulley assembly and the operational shaft thus are sources of power with which we can do work. Some of the typewriter functions are carried out by spring action, such as the movement of the carrier from left to right. Still other functions are simply manual functions, such as the tabulation stop set and clear functions. In order to enable us to readily make the distinction between the two kinds of power, we call the power which comes from the motor, the hub pulley, and the operational shaft positive power. Let us discuss this a bit more in order to make sure that all this is clear in your mind so that we may use these terms later in the program. Slide number 51. The power which comes from the mainspring of the typewriter, for example, is called negative power. By negative power, we mean to describe energy which is stored in a spring and which must be released to the mechanism in order to produce work. The negative power of the mainspring is transmitted to the typewriter mechanisms through the indicated shaft called escapement shaft. All of the mechanisms which are driven negatively or through spring action have to be recharged, or simply after we used a certain amount of spring tension in order to do work, we must restore that spring tension. The restoring of the tension or the negative power in the mainspring is carried out by the mechanisms called backspace and carrier return mechanisms. The mechanism used to release this negative power of the mainspring is called escapement. More about this will be covered in the training program entitled Negative Power. Slide number 52. As mentioned before, we think of positive power when the power supply to the mechanism comes directly from the motor. And when the motor turns, the hub pulley assembly and the operational shaft also turn, thus becoming the source of positive power in the typewriter. Whenever the operator calls for some operation, he or she wants the machine to perform a job, and the machine in turn avails itself of clutches in order to use some of this positive power. The operational shaft turns at the rate of approximately 7.5 revolutions per second. The objective of this segment of our training program is that of studying the construction, the operation, and the adjustments of the clutches which tap this positive power coming from the shaft.